Hi boys and girls. Today we are going to continue to talk about polygons, but we're going to use Venn diagrams to classify or organize those two-dimensional figures. Remember this, our polygons are 2D shapes, flat shapes, and we're going to organize them and classify them. And we've been doing that separately with triangles, quadrilaterals. So today we're going to do that with several different polygons. We are in your 10 through 20 book. We are on page 509. Our job today is draw a Venn diagram to represent the relationships among these polygons. Well, one thing that's going to help me is kind of looking at these and writing a little bit about them. So this has 1, 2, 3, 4 sides. So I know it's a quadrilateral. This has 1, 2, 3, 4, 5, 6, 7, 8. So I know that's an octagon. This is a triangle. 1, 2, 3, 4, 5. Hexagon. This is a square. 4 sides. This is a 1, 2, 3, 4, 5, 6 sided. This is a hexagon. They are all different polygons. So I'm going to have to think of something that they have in common in order to group them. So I'm going to go ahead and draw a Venn diagram. This is one example of a Venn diagram. And I'm going to think about some attributes or things that they share and some things that they don't. So we may look at them and think about their angles. This quadrilateral has right angles, so does this one, this square. We've got 4 equal sides here. This has a few equal sides. This has a few equal sides. So remember, in a Venn diagram, in here, this is things that they both have in common. If it doesn't have any of it, we can stick it on the outside. And if it only has this, then we'll put it right here. Okay? So why don't we say all sides congruent? And we'll say right angles. Okay? So one with all sides congruent, or all sides that are the same. The only one I see is the square. Oh, just kidding. I need to put that here because the square has right angles and all sides congruent. You know what? I think I'm going to change my... Let's do some congruent sides and no congruent sides. So that would be our hexagon. Square would go here. This other hexagon has some congruent sides. Our triangle does not. Our octagon has some. And our quadrilateral has some. There are lots of different ways that we could classify these. We could classify them by their angles, things like that. So again, that just kind of gets you looking at them and thinking about them. So let's turn the page. Leela is designing a video game in which the players arrange quadrilaterals. She defines a trapezoid as having exactly one pair of parallel sides. Complete the Venn diagram to show the squares, rectangles, and rhombuses are related. And let's label them. Okay, so we know all together, we know all of these are parallelograms. So we can say that's kind of like our title. And we're supposed to show how squares, rectangles, and rhombuses are related to parallelograms and trapezoids. So we need to use all of these words. Well, which one is not a parallelogram? That would be our trapezoid. So it's going to be over here. And I can see it here in her picture. Okay. So I know types of parallelograms I have. I have rhombuses. And I have rectangles. Okay, remember rhombus has 4 equal sides. Rectangle, opposite sides are congruent. Really, my square, I'll write it right there. Square is both. It's a rhombus and a rectangle. And here's my parallelogram. I'll draw it right here to go right there. So that's one way you can do it. It says, explain how the diagram would change when a trapezoid is defined as a quadrilateral having at least one pair of parallel sides. So if that was the case, then we would say that it could be some type of trapezoid. But I really don't want to get into that because we do define a trapezoid as having exactly one pair of parallel sides. And let's do this last part on page 511. We're going to still use this Venn diagram. So Venn diagrams can be used to sort two-dimensional or 2D figures by their shared attributes. Sort the polygons into the diagram based on the categories. So we have regular polygons, parallel sides, obtuse angles. Okay, so let's look at it. Remember, a regular polygon has all congruent sides. Okay, triangle. That is regular because it has all congruent sides. Now, does a triangle also have parallel sides? No. Does this triangle have obtuse angles? No. So it will only go here. I'll mark it out. Remember, we'll kind of overlap them if it does more than one. Okay, let's think about this. 1, 2, 3, 4, 5. This hexagon. These lines tell me that all those sides are congruent. So I know it's regular. Does it have some parallel sides? Now remember, parallel means they're the same distance. They're never going to intersect. So this is kind of twisted. Yep, those are going to intersect. These intersect. So this does not have parallel. Does it have obtuse angles? Yes, it does. Here's my bottom. There's my letter L. This is bigger than that. So this figure actually has obtuse angles and it is regular. So I'm going to stick it right there. All right, let's look at this triangle. This is an isosceles triangle. Remember, to be regular, all sides have to be congruent. Are all sides congruent here? No. Does it have parallel sides? No, it's a three-sided figure. Does it have obtuse angles? Yes, it does. So we're going to stick that one here. Okay, let's look at the rectangle. First of all, is it a regular polygon? That means, does it have all equal sides? All congruent sides? No, it doesn't. Are they parallel? Yes, I know that these sides are parallel to these. Does it have obtuse angles? No. Okay, I think my video got messed up. So we were here with the rectangle. It does not have obtuse angles, so we put it here with parallel sides. Our octagon has 8 sides. We might have been here actually. They're all congruent. They do have parallel. These top 2 are parallel. and it does have an obtuse angle. So it's all three. The square, it is regular, all sides are congruent. It does have parallel, but it does not have obtuse, so it goes here between these two. And our right triangle, it is not regular, the sides are not congruent, not parallel because it's a three-sided figure, not obtuse, so we stick it out here because it does not go with any of those attributes, so we stick it on the outside. And that's our lesson for today.